Welcome to this explainer. Think of your upcoming Cambridge mathematics exam exactly like a high-stakes space mission. When that rocket is on the launch pad, there is zero margin for error. Every single calculation, every trajectory, every data point must be absolutely perfect for a successful launch. That is exactly the mindset you need for your exams. Today, we're focusing our mission control systems on a critical payload, mastering trigonometry graphs of sine, cosine, and tangent, specifically decoding what examiners demand for AS and A-level mathematics 9709. But honestly, the strategies we are unlocking today apply across the board, whether you're tackling 580, 606, 4024, 4037, 4040, or even 9231. If you've ever felt like you totally understood the math, but your grades just didn't reflect that understanding when the paper was graded, you are in the perfect place. We're going to break down the exact architecture behind these questions, ensuring your mission is a resounding success.
Okay, let's dive into this pressing question that frustrates so many candidates. To really illustrate this, I want you to imagine two students sitting for their exam, looking at a classic past paper question that pulls from foundational 0580 concepts all the way up to advanced 9709 analysis. We'll call them Alex and Sam. Now, Alex looks at the question and completely overloads the page with raw mathematical facts. Alex knows the shape of a sine wave, knows exactly where cosine intercepts the y-axis, and memorized the asymptotes of a tangent graph. But there's zero analysis. It's just a data dump. On the other hand, we have Sam. Sam is racing against the clock, rushing through the paper, and totally misses the specific command word requirements in the prompt. Sam sketches a quick, sloppy graph, ignores the specific domain constraints, and moves on. When the examiner's red pen hits their papers, both Alex and Sam lose massive points. They both lost easy marks on a topic they technically studied for. Why? Because Cambridge exams aren't just testing what you memorized, they're testing your strategic execution.
This direct quote from a senior examiner really sets the tone for our session today. It highlights the high stakes of this mission. The examiner is literally telling us that most students are leaking marks unnecessarily. We are essentially pulling back the curtain on the secret playbook for securing top grades. It's not just about knowing the mathematical theory, it's about knowing exactly how to communicate that mathematical logic to the very person grading your paper. Today, we are completely shifting your perspective. You are no longer just a student desperately trying to find an answer. You are stepping into the shoes of the examiner, looking for specific evidence of understanding.
Here is our strategic roadmap for this explainer. 1. Core trigonometry principles. 2. The procedural framework. 3. Critical data analysis. And 4. Top examiner warnings.
Section 1. Core trigonometry principles. Let's start by establishing the theoretical architecture you have to build before you even attempt to draw or analyze a single curve.
Before we continue, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. All right, let's look at how top students actually structure their mathematical answers to show that logical structured reasoning. The Cambridge Assessment Framework prioritizes analytical depth over superficial breadth. Examiners aren't just looking for memorized shapes, they demand deep, systematic reasoning. And to deliver this, you need a strategy. We use the Peel framework. You might know this from essay writing, but it is an absolute game changer in mathematics. Peel stands for point, evidence, explanation, and link. Let's apply this to a trig graph. Your point might be identifying a translation in the graph. Your evidence is the specific coordinate shift you pulled from the equation. Your explanation is demonstrating exactly why changing the coefficient caused that shift mathematically. And finally, your link ties it all back to the specific domain given in the question. Superficial breadth, just knowing the basic wave shape without this Peel analysis, simply won't get you the top-tier marks.
According to principal examiner reports, candidates who reference cross-topic connections and demonstrate causal relationships achieve significantly higher marks. Let's play a quick game. Think back to Alex and Sam. Alex just dumped facts. Sam rushed and ignored command words. Neither used the Peel framework. But a top-performing student does. They use precise definitions. They show how a change in a trigonometric equation actually causes a specific graphical transformation. For instance, they don't just sketch it, they explain exactly why changing the b-value in y equals a sine bx alters the period of the wave. They link trigonometric graphs back to algebra or forward to calculus, proving they have a highly transferable conceptual understanding. Whether you're working through 0606 additional math paper or tackling heavy 9709 A-level concepts, showing this interconnected logic is exactly what sets an A or A-star grade apart from the rest. It's about demonstrating the architecture of your thought process.
Section 2. the procedural framework. Now, let's move on to the methodology and see how this theoretical understanding builds into actual, precise execution during the exam.
This right here brilliantly illustrates why you must clearly show your logical sequence. You are literally earning marks for your technical methodology. This is the method mark strategy, and it's the beating heart of the Cambridge marking scheme. Now imagine taking Alex and Sam's papers and watching those harsh red pen marks magically transform into green check marks. How does that transformation happen? By adopting the mathematics success blueprint. If you jump straight to the final answer in your head, sketch a quick sine wave, and don't document your steps, you are leaving massive amounts of method marks on the table. You are highly rewarded for the journey, for the systematic working out. The examiner needs to see your evidence and explanation from the Peel framework written down clearly. If your final calculation is slightly off due to a tiny arithmetic error, but your procedural framework is flawless, you still secure the vast majority of the marks for that question. To really lock this in, we're going to apply the mathematics success blueprint right now. We are putting Alex and Sam through a live rewrite guidance session using this exact 5-step standardized sequence. Step 1. Deconstruct the question. Sam failed here by missing command words. You need to circle whether it says sketch, plot, evaluate, or compare. Step 2. Extract relevant data. Pull out the amplitude, the period, and the phase shift. Step 3. Select your analytical framework. This is where you deploy the Peel method we talked about. Step 4. Execute with clear notation. This means no messy handwriting. Your axes must be perfectly scaled and drawn. And Step 5. Present with correct terminology. Walk through these 5 steps every single time. It's like a pre-flight checklist for our space mission. If Alex and Sam apply this blueprint, their responses immediately transform from chaotic to methodical, directly aligning with exactly what the Cambridge rubric demands.
Section 3. Critical Data Analysis. Now, what's really fascinating here is how data interpretation separates the good students from the truly exceptional ones.
Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to acetheexams_IGCS and turn on all notifications so you never miss our weekly exam strategy sessions. All right, welcome to the interactive workshop segment. We are going to test your critical data analysis skills under pressure. Challenge 1 is the data scan. Imagine a complex mathematics chart comparing a sine and cosine graph on screen, and I am putting a 60-second visual timer on the clock right now. Go. When you are doing comparative analysis of these graphs, you have to extract the core trend immediately. You must explicitly identify both similarities and differences. If an exam asks you to compare them, do not just state the obvious. Tell the examiner how they are similar, like sharing an amplitude of 1 and a period of 360 degrees, but explicitly state how they differ, such as their specific phase shifts or y-intercepts. Using comparative connectives like whereas or conversely, backed by numerical evidence, proves you've mastered the evidence and explanation phases of our framework. Time's up. Did you spot the phase shift? That's what secures the mark.
Moving right into Challenge 2 of our workshop, Find the Flaw. I want you to imagine a flawed sample mathematics paragraph analyzing a tangent graph. It says, the tangent graph repeats every 360 degrees and goes up forever. What's the critical flaw losing marks there? I'll give you a hint. Look at the evidence quality. The flaw is the lack of precision and incorrect period. A tangent graph repeats every 180 degrees, not 360, and goes up forever is terrible terminology for describing an asymptote. You must systematically evaluate your evidence, identify domain limitations, note assumptions. Now let's jump to Challenge 3, Speed Writing. You have 30 seconds on the clock to mentally draft one perfect Peel paragraph evaluating a restricted domain of a cosine curve. Time starts now. Think. Point. The domain is limited to 0 to 180. Evidence. The graph only shows the positive half of the period. Explanation. Because cosine's full period is 360. Link. Therefore, the minimum value of -1 is reached at the boundary of 180 degrees. Boom. That active consideration bulletproofs your conclusions against errors and shows the examiner you are thinking at the highest level.
Section 4. Top Examiner Warnings. For our final section, we are pulling direct, unfiltered insights from the Principal Examiner reports to help you avoid the most common traps.
The Cambridge Principal Examiner reports have identified exactly 3 major mistakes that consistently crash a student's grade. We're going to counter these with our 3 golden rules to guarantee top marks. Remember our space mission? This is the final system check to ensure absolutely zero margin for error before launch.
Here are the top 3 mistakes and how we map them to our final system. Mistake 1 is using the wrong approach for the context. We counter this with Rule 1, command word decoding. If the command word is solve algebraically, do not just draw a graph. Mistake 2 is forgetting to check format and presentation. We counter this with Rule 2, Peel framework application. Peel forces you to structure your presentation logically, so your method marks are guaranteed. Mistake number 3 is giving generic answers not specific to the given context. We counter this with Rule 3, the time management matrix. By managing your time effectively, you won't be rushing like Sam. You'll have the bandwidth to actually read the specific parameters of the question, like a restricted domain, and tailor your answer exactly to that context.
This is a fascinating examiner alert. Examiners explicitly flag that candidates consistently confuse key terminology. This is a massive red flag. When you are writing out your responses, you must demonstrate clear definitions before applying that terminology to your graph analysis. When you talk about the period, the amplitude, or the asymptotes of a graph, ensure your mathematical communication is pristine. Do not just throw buzzwords onto the page, hoping one of them sticks. Define exactly what you mean through your systematic step-by-step working out. This ties directly back into our Rule 2, applying the Peel framework correctly to explain your evidence.
Think of this table as your ultimate cheat sheet recap graphic. Look at that progress bar reaching 100% for your mark potential. To guarantee those method marks, you must follow these strict presentation conventions precisely. Notice the requirement column. These aren't just suggestions, they are absolutely mandatory. Proper headings, correct terminology, appropriate formats, and crystal clear annotations on your trig graphs are non-negotiable. If a key turning point or an x-intercept isn't explicitly annotated on your sketch, the examiner literally cannot give you the mark for it, even if your curve passes perfectly through the exact right spot on the grid.
So, by understanding the core principles, mastering the procedural framework, and countering those examiner warnings, you are fully equipped for your next paper. Students who implement these mathematics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel Ace the Exams at AC Exams IGCSE to excel in your Cambridge examinations. Subscribe right now to at AC Exams IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for mathematics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here.